Particles, points, and blocks are fine, but Pasco's new wireless force platforms allow students to see the laws of physics applied to themselves. It's quick and easy to set up the new Pasco wireless force platform or the 2-axis wireless force platform. Turn on the power button and connect using Bluetooth to either SparkView or Pasco Capstone software. I'm using Capstone, so I click on Hardware Setup, look for the sensor I want to attach, and I'm done. Create the desired displays and set the data collection rate. I'm going to display the normal force on a graph and increase the sampling rate to 500 Hertz. Make sure all 4 adjustable feet are fully extended, then place it on a flat surface. The built-in handle makes it easy to take outside or into a hallway. Readjust the feet to make sure each foot is in contact with the surface. A hex wrench can be used to make these adjustments from above. One fun challenge is to ask students if they can push down with a force greater than their weights. It's not easy. Each wireless force platform is outfitted with holes so that they can be hung from a wall for horizontal experiments. They also have pre-drilled holes for attachment of the optional handles so that they can be used to measure the force applied to something that can accelerate, like a student on a cart. Each wireless force platform comes with a charging cable for the built-in battery. The cable attaches to the bottom so that it can be charged while in use. Bluetooth connection allows for real-time data display up to about 1,000 Hertz depending on the computer. Up to 10 kilohertz is achievable using burst sampling, a trigger condition to start sampling, or by connecting it with the USB charging cable, or some combination. A high sampling rate allows for accurate measurement of brief and dynamic phenomena like a bouncing ball. The Pasco wireless force platforms can measure forces up to 5,200 newtons. That's about 1,170 pounds for you imperial types. This allows the measurement of the normal force acting on students during takeoff and landing of vertical jumps. So I'm going to hit record. And when I stand still, it's measuring my weight, right? Because I'm not accelerating. And you can create a calculation or you can tear it. So now it's reading the net force. So students can use this data first to analyze the initial squat or counter movement, which is this part here. And they also can use it and their mass to predict the jump height and compare it to the height derived from the hang time, which would be when the force is here to here. They can measure that change in time. The 2-axis wireless force platform can measure up to 1,300 newtons in the parallel direction. This allows for investigation of forward and backward jumps too. So let's create a parallel force display. And try that again. So it's the net force. Students can use the parallel data and student mass to find the forward velocity. Combined with the normal force, they can find the angle and velocity of the jump and predict the range of the center of mass. More information, including additional videos, can be found on the Wireless Force Platform product page at pasco.com. Student handouts and teacher guides for the vertical jump activity, the bouncing ball investigation, and more are in the Pasco Experiment Library. Thanks for watching.